Good morning, good afternoon, good evening, wherever you are. Welcome to another CIQ webinar. My name is Zane Hamilton. I'm the Vice President of Solutions Engineering here at CIQ. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky, Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source. Today, we are going to be talking about Apptainer some more, and we have a few people to bring on. We can bring in Brian, Dave Godlove, and Jonathan. All right, Forrest as well. Got the whole crew. This is awesome. Let's go around real quick. You guys introduce yourselves. I feel like you've all been on here several times, so I don't know that we need to do this, but let's do it anyway. Brian, I'm going to start with you.
Hi, everyone. Brian Fan here. I'm a solutions architect at CIQ. My background is in HPC system administration and architecture, and I have experience with workflows in the areas of CFD and genomics. Great to be back on the webinar.
Excellent. Thank you, Brian. Mr. Godlove.
Hi, everybody. I'm Dave Godlove. If you're new to the webinars or new to the Apptainer community, I've been around Singularity for quite some time, been around the Singularity Apptainer community for quite some time, and now I'm also a solutions architect here at CIQ.
Thank you, Dave. Forrest.
Hey, everyone. Is this working?
It is.
Cool. Good morning, everyone. My name is Forrest Burt. I'm a HPC systems engineer here at CIQ. My background is in the academic and national lab HPC space, where I was a sysadmin for a couple of years before joining CIQ. Happy to be on the webinar as well. Great to see everyone.
Thank you. And Jonathan.
And I'll go ahead and go as I'm last. My name is Jonathan Anderson, and I'm a solutions architect with CIQ. Glad to be here. My background's in HPC sysadmin, and I'm eager to see the work that we're going to be showcasing today.
Excellent. Thank you. So I think let's start off and give kind of an overview again of what Apptainer is very quickly. I don't know if Brian or Dave, you want to run through that real quick?
Absolutely. I'd be happy to if it's okay with everybody. So Apptainer is everybody's favorite container solution, which is optimized for running workflows, jobs, specific applications, things of that nature. It's been really heavily picked up within the high performance computing space. It's been around for about 6 years. It's a pretty mature product. Apptainer itself is the successor to the Singularity project. Apptainer is the Linux Foundation variant, or the Linux Foundation approved version of the Singularity project. So that in a nutshell is what it is. So Apptainer integrates really well with GPUs, with other types of hardware. It's really great, once again, for running jobs. It integrates very well with the host file system and with other things. It basically makes a lot of things that are usually difficult with containers a lot easier.
Excellent. Thank you for that. I see your video is a little bit behind, so I think maybe that's just me. All right, so I know today, Brian, you wanted to talk about CICD, and I feel like that's a term that we hear a lot nowadays from everywhere within IT, not just HPC. Maybe it came out of IT, but kind of, I think it gets overused to some degree, and I don't think everybody knows exactly what it means. So talk to me a little bit about CICD, and then tell me why I would like to do that with Apptainer.
Sure. So let's just start off by formally defining, what CI is, right? So continuous integration is the automation of integrating code changes made by multiple contributors to a software project. So in the context of Apptainer and HPC, as the solutions architect team and with working with Fuzzball, we obviously work with a bunch of different software. And we build a lot of containers, and obviously these containers need to be tested. So let me jump into maybe an example. My experience has been mostly in genomics. So let's say I am some software developer. I'm working on a new alignment, or I'm making changes to an alignment software. And these changes are going to be made for, let's say, performance purposes, right? because this is a it's a scientific piece of software, ideally what continuous integration does, or what it should show, is that when I make these code changes, I should get consistent results. So if I'm aligning, once I make these code changes, the result file should be the exact same as the file that was created without the code changes, right? And this becomes really important in the context of clinical analysis, right? Because it would be very bad if you ran analysis on a patient's genome and certain variants are called, and you make these code changes, and you know, now you're getting different variants, and someone has already made a diagnosis on the patient and they've already given them medication. So there are a lot of real world consequences that can happen with not getting your integration tests and having consistent results. So I would like to pass the mic to the team and see what your experience is in in the environments that you've worked in with containers and testing them, and whether you've automated this type of testing in the past.
So I can speak to this. When I was at my prior institution and I was starting to deploy Singularity at the time, containers out for researchers, for the most part, I didn't really do a lot of CICD with it. I was basically just kind of figuring out even just how the technology itself worked, much less trying to apply it to something like this. So my workflow was basically build out my def file on my workstation, build that container on my workstation, send it up to the cluster, and then kind of do testing there. Even that without, obviously, as you elaborated on, Brian, there's a lot of external benefits to that automated testing. Even without automated testing, I was finding that was still a fairly effective workflow to get stuff out to users, just because of the external benefits that containerization gave to me as a sysadmin and freed up my time to start looking into how I could do things like automation. But yeah, in general, this is some of the kind of first work that I've really took a deep look into that you've been working on here, Brian, within doing this type of stuff with containers. So very excited to see, specifically with Apptainer. So very excited to see how this integrates.
Dave, and Jonathan, anything you want to add about? There you go.
Yeah, I was just going to jump in real quick. Yeah, so I don't have so this would be great too. So my background is some of my background is that I used to be at the National Institutes of Health, and I used to create containers for applications that scientists would ask for. And the way in which I would do that, many other staff members would do that, is to create new containers when new versions of the applications came out, and then to do some manual testing if we had some example data and we had some example workflows that we could use to do the testing, and then to push those containers up. But sometimes it's the case that you don't test everything, or you don't test enough things, or whatever. And then a researcher will come back and say, hey, this used to work, and now in the latest version it doesn't. And so that kind of stuff would be great, for those types of situations. I don't have experience with CI/CD within the context of containers. It's kind of funny because I do have experience with CI/CD actually with Apptainer itself. So the workflow that you described is actually, exactly the kind of workflow that the developers of Apptainer have set up, to test and push out the software itself as new versions come out. So it's widely, this workflow is, it's widely used, and it's like ubiquitous.
Yeah, and it's amazing. I hadn't thought of having CI/CD for whatever reason. When I started looking at HPC and research, it's something I didn't necessarily put together, but I'm glad to see that it is something that I just missed, and it seems to be growing. A lot of the conversations I have now are people integrating that into the life of their cluster. It's not just about the people writing software, but how are they actually getting the software onto the cluster and getting the researchers going faster. So it's very exciting. And I think, Brian, you had something you wanted to show us as well, right?
Yeah. But before I show that, I guess maybe we can just talk really briefly on just continuous delivery and just kind of defining that. So in our context, like we're working with Apptainer files, and basically these definition files are being built into containers. And what continuous delivery, what it means to me is that once these containers are built, they get pushed to a registry where our customers can consume them, or we can start leveraging them within our Fuzzball product. I don't know if the rest of the team has anything else to add to that. Yeah.
I have a friend that worked at a very large hyperscaler, and she was running a large development team, and so they were pushing via their CI/CD process code to the hyperscaler about every 11 seconds. So the amount of speed and velocity that you can get out of this type of process is amazing to me.
I just got the very tail end. I think I understand the context here, but one thing I thought would be valuable in kind of an end user application CI/CD pipeline as like a service that an HPC center might provide to their end users is not only reintegrating and retesting when there are changes to the application, but when there are changes to the underlying infrastructure. Something that we would hear all the time from our end users when in a past life as a cluster admin, was they wished that they could just hand us a suite of their applications with a test case so that we could make sure that their applications still functioned properly and performed the same or better when we made file system changes or when we made scheduling changes. And that's something that I think as we see more people containerize their applications, and in so doing, making it easy to build and test them in an automated way, that might become more and more feasible at different sites that aren't able to do it already.
Thank you, Jonathan. All right, Brian.
All right, then I guess we can jump into our demo for today. So basically, I've set up some Bitbucket runners within Bitbucket, and and for today's demo, we are going to be building GROMACS. We're going to be building a container with GROMACS. So let me start off by sharing my screen real quick. And perfect. Let's do that. Okay, so I basically have the pipelines page pulled up within our Bitbucket repo. So I'm just going to build a definition file that's on our main branch. The pipeline that I'm running right now is going to be a build and push pipeline. So it's just basically just going to take the definition file, build it, and then push it with whatever tag I specify here. So let me just go and do that. So I'm just specifying this GROMACS file definition file right here. I will jump into that after we kick this build off. And for the purposes of this demo, I'm just going to tag it with CI demo. So all right, let's kick this off. And we're off. So as you can see, this build has kicked off, and what it's doing right now is building my container. So let me just jump into what exactly we are building. So as you can see here, this is basically a definition file for GROMACS. We're building this using a Rocky Linux 8.5 Docker container as our base. At the top here, we have LD library path and path set in our environment. And basically what this just ensures we have access to the correct libraries and binaries that are in our path. And then at the bottom here, we have this OpenMPI variable that allows us to run OpenMPI workflows as root. And this is because within Fuzzball, your jobs are run as root, but it is not a privileged user. So let's jump into, I guess, the post section of this file. As you can see in this section here.
Brian?
Yep. Yep.
Can you make that? Can you zoom in a little bit? It's a little hard to see.
Oh, yes, for sure.
Maybe it's just me, but there we go.
There
Much
we
better.
go.
Thank you.
No problem. So, as you can see, we are installing some dependencies just through DNF right here. In this section here, we are installing some NVIDIA drivers and CUDA. And then in this third section here, we are installing some AWS EFA stuff. And basically, this will allow us to leverage the instance types that have EFA on AWS. So an example of this would be the C5N instance type. And then finally, we are pulling down the GROMACS source, and we are building it against EFA. Cool.
Hey, Brian, I got a quick question for you.
Yeah.
You know what GROMACS? What is GROMACS?
So GROMACS is a molecular dynamics software. It runs through using MPI and is embarrassingly parallel. I'm not sure that is my understanding of it. I'm definitely not a power user of this software. But Forrest, if you have anything else to add to this, yeah, by all means.
I was just going to say that basically covers it. GROMACS is a pretty standard molecular dynamics suite. It's really commonly used very popularly in the kind of pharmaceutical field for doing drug discovery and that type of stuff. So like take 500 candidate, pharmaceutical chemicals, test them against certain tissues and types like that, and do simulations of that. Performance comes out in like nanoseconds worth of simulation a day. But essentially, one of the biggest use cases for this is pharmaceutical drug discovery.
Cool. Thank you, Forrest. All right, so we've basically covered what we are building. So let me jump into, I guess, how these Bitbucket runners are kind of set up. So the type of Bitbucket runner I'm currently using is the Linux shell runner. I can jump in, and these are configured using a Ansible playbook that I wrote. The Bitbucket runner is basically just this Java file. It's a jar file, so I'm installing Java here. On my instance, I'm also installing Apptainer, creating a Bitbucket runner user, and then finally pulling down the Bitbucket runner and installing it. Basically, let's see, what else do I do? So down here, I basically turned this Bitbucket runner into a service. Basically did that just because in case our server gets rebooted, ideally I just want the service to come back up on its own. Setting up a Docker config JSON here. The reason for that is we are going to be pushing containers to our Google artifact registry. So within this Docker config file, I am basically configuring Apptainer to use the Google Cloud Credentials helper. And then last but not least, I installed the Google Cloud CLI so that I can authenticate with GCP and actually push the build container to our artifact registry.
And Brian, I just want to make sure I understand here. So this configuration here, this bit of Ansible, this is configuring a conceptually arbitrary Linux machine to be a Bitbucket runner. This isn't something that is executed every time an integration happens. Is that right?
Yes, that is correct. So typically you would only need to run this once. So how I've set up the host file is that I give it the IP of the host, and I also pass it some variables that Bitbucket gives you. So these are things like OAuth client IDs that are specific to each Bitbucket runner. So after you've set one up after you set up your runners within the Bitbucket UI, you can populate the host file with these variables and then run the playbook against the instances. Ideally, like with the OAuth client IDs and stuff, currently they're in like plain text for demo purposes, but in a production environment, I would ideally like to access these with something like Vault, for example. Cool. So Last but not least, we can jump into the actual build and push script that's actually doing the work, most of the work for this CI/CD pipeline. So this is basically a bash script. It takes a file and a tag as a string and basically does a little error checking here just to make sure there's no spaces in the tag. Make sure that the file actually exists, and if it actually exists, we basically using the file name figure out a image name and give it an image path to build to, and then start the build. And then once the image is built, if your container file has any tests that are specified within the tests section of the definition file, then it'll run those. If you didn't specify a tag, I just tag it with the git commit hash. And then finally, I basically authenticate to Google Cloud with our service account that has write access to the artifact registry. And then finally, the image gets pushed. Yeah. So that is the script that we're running today. Yeah.
Brian, can you give an example of the kind of tests that, like, are there any tests on this GROMACS one, for example, or what might someone do to test their container?
So in terms of HPC software, my ideal test would be like the smallest possible test case that uses some form of input for the actual piece of software. But if you're trying to do just a quick sanity check just to see if your application actually installed correctly, I would just call the binary and try to get a help message out of it.
Sure.
Yeah.
We do have one question.
Yeah.
Brian?
Sure.
I can throw that up from Sylvie. Oh, different one. Do you have an opinion on containers and commercial ISVs? Should the ISVs build a container, or does it have too many security consequences?
I mean, I think most ISV, in my opinion, from the ISVs that I've worked with in the past, I'm a firm believer that their software can be containerized and can be used as a better means of distributing their software to the end user. Not sure if the rest of the team has any strong opinions on that, but yeah, I'll pass the mic to y'all.
There are definitely considerations, especially in 2022, around like the software bill of materials. So knowing the exact provenance of where your containers come from is important, whether that's something that the company has built and is giving to you, or something that you're building and distributing out to your users. Maybe I'm pointing out the obvious, but I would say that some commercial software vendors, it's going to be very difficult. I agree. I think most things can be containerized. I think that is the future there. I think one of the biggest problems there is just going to be being able to get access to the proprietary software and all the build instructions and things like that to do it yourself versus having that prepackaged from an ISV. I'd say that if you're going to get that from a software vendor, they should probably be looking at, like their own software bill of materials and stuff, just like you should be. So just making sure that, if you are getting containers from them, that they're, doing their due diligence necessary here in the modern world of containers to ensure that you're getting a safe product. Which ultimately a lot of that stuff is stuff that you should be doing as well if you are containerizing software and serving it out to your users, whether that be open source or proprietary solutions that you actually have the means to be able to build.
Yeah, and I think I'm on board with the other people. What's been already said. It would be good if more ISVs upstream were publishing containers for their software. Alongside that, if there are any security concerns, what I would want to see it as a user of that container or of that software is just the container file that was used to build it. And even if your application isn't open source, like the container build file, whether it's an Apptainer build file or an OCI build file or anything, it's really just a script that would be akin to the installation instructions for that software. But then you get to see exactly how they built the environment that they run their tested environment in, or run the tests for their application in, and that would let you rebuild the container yourself, presumably, even if their code is proprietary and not open source.
And I would add to that, you want to make sure also that the container that you get, this might go down a rabbit hole, but just real quick, the container that you want to make sure that the container that you get was actually the one that was built using that definition file. So this is a great place to ask the vendor to cryptographically sign the container, and to make sure they communicate to you the fingerprint of their signature, so that when you have it at your, shiny little terminal, you can go ahead and verify it and make sure that that same fingerprint comes up. And then if you like, you can use a Apptainer inspect-def file and start going through that definition file and see how they came up with what they came up with. Because if they, signing it is great, but if they signed it after they built it from an untrusted source, that's not so great. So you want to also make sure that, Provenance, you trust the author, and you also, you're happy with their sources, where they started the container from.
Thank you, Dave. We do have one more question, I believe, from Sylvie. What improvements would you make to your CICD pipeline?
Oh, that's an excellent question. So I was actually pondering about this morning. One of the big limitations with the Bitbucket Linux shell runner is that I can only run one build per instance. And I was actually thinking about how can I be able to run multiple builds using the Linux shell runner on a single instance. So the way that I thought of to approach this was to basically install the Bitbucket runner within Apptainer, and then have start it as a Apptainer instance. And then that way you can, in theory, I should be able to run multiple builds within an instance. So, that is definitely something I'm going to test. And if I do get that working, hey, that'll be a future webinar that we'll be doing.
Very cool. All right, Brian, were you going to run this and show us something else?
Yeah, so let's go back to our build, and let's just see where this is at.
You could make that a little bigger if you don't mind,
Sure.
too. There you go.
And we are at the point of oh, okay, perfect. So as you can see, we've basically run through the GROMACS install here, and down here you can see it's creating the CIF file, and then finally the CIF file gets created. In the GROMACS definition file that we are looking at, there were no specific tests that were specified, so it basically didn't run any tests. And then finally, we authenticated with Google Cloud and pushed our built image to our artifact registry. Cool. And yeah, that basically concludes my demo. So I will stop sharing my screen, and yeah, we can start wrapping up.
That's great. I mean, if you guys have any other questions, start throwing them in there, but I kind of want to go around a little bit and ask. So, I mean, we talk about the Bitbucket runner. What exactly is a Bitbucket runner?
So a Bitbucket runner is basically a service that waits for build jobs to build jobs within Bitbucket. So let's say I kick off a manual build. Bitbucket runner will listen for one of those tasks, and if there is a task present, it will pick it up and run whatever build you've specified. And these builds could be like building a container, or in different environments, this could also deploy to like your production environment, for example.
And then maybe this is a question for a different topic, but how does that relate to some other tools like CloudBees or Jenkins?
So it's basically like how my understanding of it is basically it's Bitbucket's version of like GitHub runners, for example.
Okay.
Yeah.
Yeah, so Jenkins
Right.
would be like a more genericized third-party one of these that isn't tied to any particular source repository. But as the source repositories have become a greater and greater source of truth for all of these things, GitHub was one of these, Bitbucket has one of these. I think, yeah, GitLab has one of these if you're doing self-hosting or using their services. That's the one that we used in a past life of mine.
Thank you. So James asks, my environment has strict security requirements and containers need to be encrypted. How do I achieve this with Apptainer? It's a great question for Dave.
Yeah. So there's two different kinds of encryption kinds of things within Apptainer, and sometimes they get confused a little bit. But I think the one that you're asking about is actually encrypting the container so that it can't be read. And so the way in which you do that is that you generate a key, and there are commands within Apptainer, actually, because Apptainer is a really full-featured program. There are commands, helping you to do that. There's actually some documentation online too on the Apptainer website for how to create. Actually, I'm wrong. You don't create the key for encrypting the container within Apptainer itself. You create your key outside of that workflow. But in any case, once you've got that key, you can go ahead and encrypt your container using the public key material. And then whenever you decide that you want to run it, you can decrypt it using your private key material. And so the way that this works is that a CIF file, Singularity Image Format file, is basically a squash.fs image with some other partitions in the file with some other metadata associated with it. Once that's encrypted, those different partitions become encrypted so that they can't be read when they're sitting on disk. And in fact, they remain encrypted even when you run the container, so that they're only decrypted within the new mount namespace, so that they remain encrypted on disk or obviously in transit. So maybe we can post in the comments after the webinar. We could put a link to that documentation, but it's pretty well documented within the Apptainer documentation how to do that encryption and decryption workflow.
Yeah, and handling that encryption key wouldn't be that difficult for a CI/CD workflow, because, like you pointed out, Dave, you encrypt with the public key and then you use the private key to decrypt. But if you do want to do signing, which you might want to do alongside your encryption or even separately, you would do that with the private key material. But I think, Brian, that as part of like pushing up to Google Cloud, you're already handling secrets. And I know you mentioned this, or you touched on this as you went on. Could you talk a little bit about how storage of secrets works and how you might store a private key for,
definitely.
container signing as part of the CI/CD workflow?
Yeah, for sure. So within Bitbucket, within Bitbucket, you can set for your pipeline runners, you can set what they call secure variables. And basically, once you set these within the UI, within your build job, you can access these variables. And if they're configured as secure variables, even if you try to echo that specific variable in your script, it won't actually echo it, and it'll just echo the variable name. So that's how I've been handling our GCP secrets using that method.
And I think I've seen, just to randomly note, that you can do that same thing on like GitLab CI/CD, just in like one random thing that I was tinkering around with this. So that's common to all those platforms to be able to secure those variables like that.
Thank you, guys. Sylvia asks, how are consumers of my container able to trust the container they are running? I think this kind of goes back to what you were talking about a little bit before, Dave, but this is the cryptographic signing, right?
Yeah, so this goes back to signing and verification. And so maybe I could explain a little bit the entire workflow. So let's say that, so Sylvie, you have created a container and you are sending it to another user or another scientist or whatever, and they need to run it and they need to be able to trust it. So the workflow for that is for you to go through the workflow of creating a key and then signing your container, and then sending, in like out of band in a different method, sending your downstream user the fingerprint to that signature. And so then, let's say I'm the downstream user who gets your container. Okay, so I get this container, I pull it down, it's completely untrusted. I have no idea who created it, what's in it, whatever. So the first thing I want to do is I want to verify it. So I would run something called a Singularity verify, which is going to do two things. It's going to check that the container actually is signed, and then it's going to actually tell me the fingerprint of the key that it was signed with. And so once I do that, then I can compare the finger. So that tells me it's signed. Once I do that, I can take the fingerprint, I can compare it to the fingerprint that I obtained from you out of band. And if they match up, that tells me it's signed by you. So now I know that it's not only that it's signed, but it's also that it's signed by you. And so that lets me know now that this CIF file that I've got is a bit for bit reproduction of the one that you created. Now the next steps have to do with whether or not I trust you, right? And so this comes down to, and this is why the Apptainer model of letting anybody sign and anybody else verify the container, it sort of crowdsources the trust out, right? Instead of saying we have a central repository somewhere where we're going to store all like official images and we're going to sign them as a team, and then you just trust us. In this crowdsourced version, you decide whether or not you trust the person who originally created the container. So, and then trust also comes down to two things. Number one, do I think that you're malicious or not? Hopefully, that's a pretty easy one. Hopefully, I know you and I don't think you're malicious. But then the next one is a little bit more complicated. It's like, do I trust that you know what you're doing at a very high level, in fact? Because it can be very easy, and it is, in fact, the usual use case to grab a container when you're building it from an existing container somewhere, up on Docker Hub or somewhere else. So do I trust that you know what you were doing when you built that container and when you grabbed it from the sources? Maybe instead of building it from another container, maybe it would be nicer if I can look in the definition file and I can see that you actually built it from the upstream operating system mirrors, because those, have a higher level of trust implicitly than existing containers, which are sitting up on a registry somewhere. They kind of have to, because all of us who are running Linux anywhere need to trust those mirrors, right, in order to just run Linux. So, okay, so that's like, hopefully I went through all the different aspects of it, and there's a lot to it. It's kind of complicated, but it's necessarily so.
That's great. Thank you, Dave. Go ahead, Forrest.
Just to build on that, I wanted to mention, I think I used this term earlier, but I'm not sure if I defined it very well. One thing that is kind of starting to come out in the world of containers, for a long time, we've all kind of had this good faith assumption that the containers out on the Docker Hub are not malicious. The container, it's not going to have a crypto miner hidden in one of those layers or something like that. There are starting to be more cyber attacks and things like that. There's starting to be more concern in general about where exactly, as Dave was touching on, like the software that's building these base images that are out on Docker Hub is actually coming from. So one of the things that's starting to become very big in this field, like I said, I think I said this earlier, but I'm not sure if I defined it very well, is what's called an Sbomb, or software bill of materials. Much like how, if you were building a jet fighter or a tank or, anything, you would have a full list of where everything was sourced from, and you would be able to trace back to every manufacturer, every, steel plant, every, bolt manufacturer, whatever, exactly where every piece of that machine came from. With software, software systems reach a similar level of complexity at times in their own ways. But we haven't, especially as related to containers, had that formalized, where did this entire container that we're using, to run our multi-billion-dollar website, and that we have, a million nodes sitting out there all running at once, what, like literally, you might have, thousands, tens of thousands of machines all running this one container at once, which is some incredible scale to have that much metal working on something. And so ultimately it's like, well, what is that actually running? And so one big concept is starting to come out here around, like I said, seeing, if that software came from the mirrors and came from the, the repositories, that type of stuff. is that software bill of materials that gives you the ability to trace back the exact provenance of all the software that went into building your container and know for a fact that it was built by a trusted source and it's not just coming from somewhere random. So that is kind of really big. And I don't have a specific thought that I can say about Apptainer and integrating that inherently. It does all of its signing and stuff like that. That's very useful. So you can hypothetically, for your custom applications, you could have someone on your team sign off on them, build them at a very, very basic level. But I know that those are things that we're very interested in exploring. So we are definitely up on the software bill of materials and the provenance of software wave that's going on right now within security.
And it's one of the things that's absolutely bolstered by just the process of building your containers as part of a CI/CD pipeline.
Yep.
If you're building containers manually and someone's having to manually construct a bill of materials of what's in that container and sign off on it with the key, that's an error-prone process. It's very detail-oriented and finicky, and it's easy to miss something when you're building the same container over and over again, even if you're only talking about the released containers. The goal with doing something with a CI/CD pipeline is that all of that's automated, and the same process that's building the container in the first place is the process that is then cataloging what went into it and signing off on that as a holistic process.
That's great. Thank you, Jonathan. So guys, I think if we don't have any more questions, if we're up on time, go ahead and wrap up.
Well, I have one more question. I actually have one more question, if it's cool for Brian. So you demoed, so this demo was great, and it was focused at an admin perspective, I think, of how do you set up this CI/CD pipeline. What I'd like to know is, just a little, you don't have to show, but if you could just talk a little bit about what is the look and feel of this for a user. So let's say somebody's already set this up. I've got experience with CI/CD pipelines that are set up in which what it looks like for me is that I push some change to some repo somewhere, and it, ends up, because of the pipeline, which is there, that kicks off a build process, which creates an artifact. In this case, the artifact is the container, and then that lands somewhere. Is that fundamentally pretty much what this looks like, or are there differences there?
For the end user, I guess it really depends on what you're doing. If you're creating a scientific application, I think it would actually follow that type of process. But let's say if the end user is more like a bioinformatics user that runs workflows using multiple containers, and if you were to have let's say a fuzzball YAML, for example, that's pushed to a repo where you're making changes, ideally you would have a CI/CD pipeline with that, where you have some input file, and then you run your workflow on it with all of these updates to all of these different pieces of software, and you should have some expected output that should be consistent. And that's basically CI/CD from an HPC user's perspective. Yeah.
How about
one more follow-up? Oh, sorry. Go ahead, Forrest.
I was just going to say, what about for parameter sweeps? Would this be something where, for example, you could kick off your CI/CD pipeline to take maybe an example use case of yours and try to find on your specific architecture, it runs, 248, 16, 32, 64 cores, different configurations, tries to determine what's most optimal, and then reports that back out to you so you know what the most optimal way to run it on that architecture is?
For CI/CD, I probably wouldn't run it within a CI/CD pipeline, but I think that would be a really good use case for a fuzzball workflow, where you can have just a single job, just multiple different resource configurations within that one fuzzball YAML, and then you can just fire off all of those jobs at once.
I like that. Yeah, that's a great idea.
And then one more quick follow up. So this is another potential use case. Could this be possible with this pipeline? So you use the example of GROMACS. Let's say I'm an administrator who's responsible for making sure that the latest and greatest version of GROMACS is always up to date on the cluster. Could I set this up in such a way that it's triggered on a major release of GROMACS within their repo somewhere, and then every time there's a new major release, it automatically builds a new container and, pushes that someplace that I can check it out and then pull it down to my cluster? Or?
I think it definitely is possible. I think the biggest challenges in doing that is just monitoring for those actual GROMACS releases with the installation of the software. So the installation process across different versions is usually pretty similar. I was actually thinking about, it would be really cool if Apptainer had like some templating functionality where like you would just have the install script and all you would need to do is template out the version, and then you boom, you have a new contain, the latest version of the container. And yeah, those are my thoughts on that.
Thank you, Brian. So we have one more comment that got made. If I can throw that one up. There we go. I think this goes back to when Dave was talking. So he points out the third point that could have been thrown out. Can I trust the container to be updated if vulnerable or vulnerabilities get discovered in dependencies later? That's always going to be an interesting one to.
There's definitely quite a matrix to keep track of with all the component softwares versus all the CVEs that are out there. This goes back to kind of what we were just discussing with making sure that you're keeping things up to date. You're still doing your due diligence on what's out there and keeping up with the industry and things like that. I don't know like what type of mass CVE matching schemes there are out there to like apply, like I said, all the software in this container to the possible CVEs for it. That starts to feel like a supercomputing task at times with how big that matrix could possibly get. But I have seen, like for example, after Log4Shell came out, for example, a lot of different places added verification, like Docker Hub, I think added some type of verification specifically just for that bug. And so, or for that vulnerability. And so a lot of containers now have like no, Log4Shell CVE detected. So I know that it can be done automatedly. And in some places I've already kind of looked at doing that for some of the major ones that have come out. But I can't speak to exactly what, like I said, doing that like matrix between all the CVEs, all the software looks like, because that could be very, very complex to be able to, like I said, build that entire tree out. But I'm sure it can be done. So
I'd like to take this opportunity to pull on a thread a little bit and talk about something which is a very kind of nasty topic. And once you start to get into it, and I don't think that the security community is really clued into this. I think they are clued into it, but what's the solution? There's not a good solution is the problem, at least not presently. And this is that a CVE is not just a CVE across the board. There are vulnerabilities within operating systems that are reported as, really high magnitude vulnerabilities, which are, really critical to patch, which don't amount to a hill of beans within a container, depending on the container environment that you're running them in. And vice versa. There are things that pop up in containers that, no big deal if it was on your operating system, but because of the containerized nature of where you're running this, it becomes a real problem. And scanners and things aren't, they're not, they don't differentiate between this. They basically just go check databases and say, oh, well, you've got this file or, whatever. And so that means you're vulnerable. And so, I mean, if you really, really want to do your due diligence and figure out what's going on, you have to do something like use a tool like Sift or whatever to create your Sbomb within your container, and then use something like Grip to flag all the CVEs. But then the next step, which is hard, which I don't think a lot of people go through, is you actually have to go through those CVEs and do some research and go to MITRE or whatever and look and see, what they're all about and whether or not they actually are a problem for you within your container. And, you may be able to get rid of, just like, delete files and things, but at some points you might not be able to do that. And at that point, it's good to know, like, if you even care if this CVE is even something which is going to affect you within your container. The flip side of that, which I said, I don't even think is being addressed at all, which is there can be CVEs which can affect you within containers, which are not being reported at the operating system level because they're not problems within the OS level. So I don't know. send me a nasty mail if there is something like this, but I'm not actually aware of scanners that they're finding stuff like that right now. And it's an incredibly difficult task, because those would be all specific to the container environment in which you're running them. So you need like a different scanner for every environment. So this stuff gets really, really messy and really ugly really fast. And I don't know. I think that it's not being addressed because there's not really like great ways to address that kind of stuff as of yet.
Yeah, go ahead, Forrest.
Just to say one more thing about the first side of that. You said not bugs existing in containers that don't exist on the operating system. Within Apptainer itself, there are a number of different capabilities that have been built into it over time that, like Dave said, kind of outmatch an entire class of vulnerabilities that can be done within a container just because of how it's built there. I'll just point out one example that I have on my mind because I think it's on our YouTube channel. There was a pkexec vulnerability earlier this year that we found almost immediately you couldn't even do in a containerized environment. It was just natively blocked and didn't work from inside of it. So that's definitely an interesting side of it to see, like everything that's been built over time into this to ensure security, but I hadn't thought of that as well. What can actually affect a container that can affect the host? I would imagine that some of that would end up coming up as bugs on our end. But it would be interesting to explore that concept more, exactly what the differential there between, yeah, that's interesting. Especially
while
like
listening to
containers. Sorry, Jonathan.
While listening to Dave talk about, well, and really just this whole part of the conversation, CVE detection or vulnerability detection within the container, it's actually changed my mind about the way I've thought about containers a little bit. I've in the past half jokingly been cynical about containers as reinventing static linking, and just part of the continual go back and forth between dynamic linking of applications versus static. And now we have statically linked our entire OS together into one file. But where that's wrong, where I was wrong to kind of dismiss the concept that way, is the way the container packages it all up together. You do still have the full understanding of what component parts go into this full stack. So you get to treat it like this statically linked thing that you can pass around as a single CIF. But when it comes down to actually scanning it for vulnerabilities, you can, as though it were not all packaged together, look at the packages that went into it, the versions of the libraries, even if it's some crazy non-distribution thing that just has files in there, you can still scan the libraries that are present. And so while it is work, I'm glad to realize that the way it works at least makes it possible.
Oh, thank you, Jonathan. So I know this seems like a topic that we could go down for a rabbit hole for a long time and probably turn into its own webinar and bring in container security and scanning experts, but we'll do that at some point. So I'm going to go ahead and wrap up because we are getting close to the top of the hour, and I really appreciate, Brian, you putting this together and showing us and walking us through that. It's always good to level set on what things are and make sure that we're all using the same vernacular. So I really appreciate it. Guys, I appreciate you being here today. Guys, if you would like and subscribe, and we will see you again next week for our roundtable. Thank you.